So we'll continue our discussion on joy of x, a guide to our mathematics for infinity. Today we'll talk about integration, calculus. Actually, yesterday we talked about calculus derivatives. So here we will talk about integral. So at what to be summed, it depends on the context. Okay, in astronomy, the gravitational pull of the sun on the earth is described by an integral. It represents the collective effect of all the minuscule forces generated by each solar atom at their varying distance from the earth. So to understand why sums like these requires integral calculus, not the ordinary kind of integration we learned in grade school, let us consider what challenges we face if we actually try to calculate sun's gravitational pull on the earth. The first difficulty is the sun is not a point. Neither is the earth. Both of them are gigantic balls made up of stupendous number of atoms. So every atom in the sun exerts a gravitational pull on every atom in the earth. Of course, since atoms are tiny, their mutual attractions are almost infinitely small. But because they are also infinitely many of them, in aggregate they can still amount to something. Somehow we have to add them up all. This is how the integral calculus solves this problem. But there is a second and more serious difficulty. These pulls are different for different pairs of atoms. Some are stronger than the other. Why? Because the strength of the gravity changes with distance. The closer two things are, the more strongly they are attracted. The atoms on the farther side of the sun and the earth feel less attraction. Those on the near side feel the strongest. Those in between feel strong forces of middling strength. Integral calculus is needed to sum all these changing forces. Amazingly, it can be done, at least in the idealist limit, where we treat the earth and sun as solid spheres composed of infinitely many points of continuous matter, each exerting infinitesimal attraction to others. As in all calculus, infinity limits us. Basically, this was integral calculus introduced, developed by Newton and Lavoisier. Okay.